Good morning, everybody. Today we're going to do a lesson on populations and then also on carrying capacity. So what I have up here for you right now is a picture, sort of like the human population from 2 to 5 million years ago up until about 2025. Okay, so look at some things that you notice. It stayed pretty steady, right, for the first 2 million years or so. Then we actually started to see a pretty good increase. Then here in the 1800s, this is when the Black Death or the plague came around. You know that nice song that we sing with our children or when you were little, like Ring Around the Rosie? This was actually about the plague. So let's talk about that song for a minute. So, Ring Around the Rosie, pocket full of posies. What do you think that means? What they did is there were so many people dying and they smelled so bad that they put a ring of flowers around their neck, which was like a Hawaiian lei. And then they also put posies in their pocket, which is a very fragrant flower. So they would smell that instead of the dead bodies. Okay, so ring around the rosy, pocket full of posies. Ashes, ashes. What does that mean? Remember from history class, they actually burned all the bodies because there were so many. And then we all fall down. They actually thought that was going to be the end of humankind. Of course, millions of people died, but we bounced back. And then after that, the Industrial Revolution took place. And from then on, where we had medicines and we could transport goods and things like that, people started living longer and prospering. So since then, our human population has grown exponentially, which means it doubles every so many years. Okay, and that's one of the problems we have today. So let me just show you this website super quickly. And you can get to it anytime you want to. It's a worldometer. This is the current world population, okay, which you know when you're calculating a population, it's the number of people being born and the number of people dying. So it's birth rate minus death rate. All right. Now you can see the number of people being born today, the number of people dying today. And of course, guys, it doesn't mean that as soon as someone pops out and they're born or as soon as someone dies, this ticker goes off, right? It's just a conjecture. So obviously we have way more births than we do deaths, and that's why our population is growing so quickly. Okay, now keep in mind that in populations, it also includes immigration, so like the people coming in, and immigration with an E, people exiting. Okay, so if you're doing a true population, it has to include that as well. All right, so let's go back over to this. All right, so I just want to show you the difference between linear and exponential growth. I know you guys have done linear and exponential in a math class. So linear basically means it's, steady. And then exponential means it's doubling every so many years. And that's what our human population is currently doing. Okay? All right, so let me show you another thing that, let me move this down here. Put it right there. Okay, so I like this actually a little better. It doesn't show total population. It shows the gender of the individual and their age. So you can actually get a lot more data off of these. Okay, so let me show you the difference here. So this is like Kenya, Nigeria, Saudi Arabia, so Asian and African countries. You see how the bottom of this so-called pyramid is really wide and then it's thin at the top? So if you see something that looks like this is rapid growth. So that means those countries, their population is growing very rapidly. Okay? Now this one, Australia, Canada, the United States, see how the base is actually narrower, if that's a word, than rapid growth? This is slow growth. So yes, the United States population, the Australian population, the Canadian population is increasing, but slowly, okay? Now, this one over here is showing zero growth because it looks pretty even all the way up. So Austria, Denmark, Italy, a lot of European countries aren't growing at all, okay, which can be a good thing and it can be a negative thing. So let me show you these. Okay, so this one here, and I think that's going to move that off. Let me move it over here for a minute. Okay, this one here is showing rapid growth. So the ones I just showed you, Kenya, Nigeria, Saudi Arabia. Okay, the middle one, slow growth, zero growth, but this is a new one for you. Let me show you this one. Okay, this one here is negative growth. So see how the base of this shape is smaller than the middle and the top? Okay, so that means this is negative growth. I'll show you here. Negative growth. So Germany, Bulgaria, Hungary, and some other places in Europe are actually shrinking. Their population is on the decline. Okay, so just so you can see those different things there. All right, now let me get us back in the middle here. All right, and we'll move on. Okay, so here are a couple other ones that you guys can look at. So what would you say about Mexico? See how wide it is on the base and how narrow it is on top? Mexico is showing huge rapid growth. Okay, Iceland is showing slow growth because all of these things are steady here. And then Japan is, this one's kind of hard to tell because it's small at the bottom and then wide here and smaller here. Some people would say it's not growing and some people would say it's actually steady. But you know how Japan is completely overpopulated on that small island anyway. Okay, now I just want to show you the difference. Here's United States, okay, here's Africa. So there's quite a bit of difference here, and this is, I wanted to show you a first world country and a third world country. So we already said that United States was growing slowly. We knew that, okay? Africa is growing quickly, but look at the big difference when you get up here at the top, okay? So obviously Africans don't have as long of a lifespan as Americans do. And that can be contributed to a lot of things, right? They don't have modern health care, you know, they don't have the conveniences that we have over here in the United States. All right, I'd say pretty much equal boys and girls, right? Wouldn't you? Okay, and then you can also tell who lives longer. So up here, you see how the pink side, the females live longer than the males. And that is true. The average lifespan of a female is a couple years older than a male. In Africa, it's the opposite. Males live longer than females. Okay. All right, so here's two more graphs, China, and this one on the right here is India. I don't know if you can see that word there because my face is there. Okay, so you remember China is one of the countries that actually put laws that you could only have one child. It may be two now. I can't remember if the laws changed or not. Okay, so they had to put a rule about having children. India doesn't have that. So they live longer in China than they do in India. Okay, and life is very different in these two countries. Rapid growth, actually no growth, I'd say, for that one. Okay. All right, so I want to see if you can see how China has actually changed over the last years. So see how it had a lot of growth in the 80s, and then now they're projecting it out until 2050. And then it'll be a steady growth. Okay, and I think part of that is because they put those rules in there about how many children you can have. Okay, all right. So guys, I want to show you this one too. This is interesting. So this is the population of Botswana, which is a country in Africa. The blue is what the country would be if the disease AIDS didn't exist. So the blue is taking out thousands upon thousands of people. So the brown is what it is today. The blue is what it would be if we could get AIDS under control. So AIDS is actually killing a lot of people. And you know, that goes with the rumor that a lot of people say that AIDS is a method of population control. Don't know if I believe all that. Okay, we're going to practice all these in a minute. All right, so I'm going to skip over that. The last thing I want to go over with you today is carrying capacity. So have you guys ever been in an elevator or in a boat or in a restaurant or something where it says like maximum capacity is X number of people or X number of pounds? That's what a capacity is, right? Well, a carrying capacity in terms of an ecosystem is how many of the organisms that it can naturally hold safely, where everybody can get enough food and water and all of those things. Okay, so what controls that are called limiting factors. So is there enough food to support all those organisms? Is there enough water, shelter? How many predators are there? What's going on with the climate? What's going on with accidents? Okay, so let me show you an example of that. All right, so here's where we start out with breeding stock with these animals over the winter, and then obviously spring hits, and that's usually breeding season, right, for a lot of animals. So notice how the population skyrockets, okay? Then we're up here, and then starvation, diseases, the weather, hunting, accidents, all kinds of things happen, and then we end up back down here basically where we started, okay? So that number there would be carrying capacity. Basically how many organisms the area can hold safely, okay? So here's a good example of that one too. The blue line is generally carrying capacity. Do you see how it levels off? It goes up and down, up and down, up and down, but it levels off. So I would say the carrying capacity of whatever this is a little bit more than 1.5 million organisms, okay? Whatever that may be. All right, so let's use this one as an example here, okay? And then I'll stop and let you practice some and do some graphing. So this is an island in New York. It's called Walla Walla Island. This is a real thing. And the deer population goes from like, what, 0 to maybe 100 individuals on a particular island, okay? So tell me, for number one, why do you think the population could be so low at A? Well, it could have been before breeding season. It could have been after a hunting season, right? They could have starved to death. Who knows, okay? What's going on during B? Well, see how the population's increasing? There's only one thing that can happen if you're on an island, and they're reproducing, okay? So they're making more and more baby deer, all right? So then what's happening at C? See how it's decreasing? So my guess is we've got too many deer, and they're probably starving, okay? So then at D, this is what we call carrying capacity. See how it leveled off for years and years and years, right? So how many deer can this island naturally hold? All you have to do is kind of, you know, find the best fit for this line here. And I'd say it's somewhere right around 80 deer, maybe 78, 75, something like that. So you would say the carrying capacity of this particular island is 75 deer. All right, so does that make sense about carrying capacity? It's the amount of organisms that an ecosystem can safely, naturally hold. Okay, so what I'd like for y'all to do next is I'm going to have two activities for you. One for you to do some population graphs, like some of the ones you saw previously that I skipped over, and then I'm going to have you do a graph on some KBAB deer, and then I might have you do another activity with populations if I can get it to work. Okay? Email me if you have any questions. I hope you have a great day. Bye-bye.